Hello, curious minds. We've explored moons that hide oceans, moons that erupt with icy geysers, and moons that orbit distant worlds like Neptune and Saturn. But far out in the outer solar system, Uranus has a moon even more mysterious, one that may have once had an active, changing surface. Discovered over 2 centuries ago, Titania was the first of Uranus's moons ever found. In 1787, the astronomer William Herschel, the same man who discovered Uranus itself, pointed his telescope toward the distant faint planet barely visible to the naked eye, and noticed 2 small points of light moving around it. Those tiny specks were Titania and Oberon, the first moons ever discovered orbiting Uranus. Back then, telescopes were far from powerful, and these moons appeared only as faint glimmers of light. Yet, Herschel's discovery hinted that Uranus wasn't alone. It had a system of companions orbiting it, just like Jupiter and Saturn. Today, we know Titania is the largest moon of Uranus, spanning about 1,578 kilometers, or roughly 981 miles across, roughly half the size of Earth's moon. It circles Uranus at a distance of about 436,000 kilometers, or 271,000 miles, completing one orbit every 8.7 Earth days. Titania is made of roughly equal parts ice and rock, giving it a dense frozen interior. Temperatures can drop to nearly 200 degrees Celsius or about 330 degrees Fahrenheit, making it one of the coldest places in our solar system. And here's something fascinating. Because Uranus itself is tilted almost completely on its side, Titania's poles spend decades bathed in sunlight, and then decades in total darkness. Imagine standing on a world where a single day can last more than 40 Earth years. At first glance, Titania might look like a frozen, lifeless sphere, but up close, it tells a story of violent impacts and ancient upheaval. Its surface is a patchwork of craters, cliffs, and enormous canyons, all carved into ice as hard as rock. The most striking of them is Messina Chasmata, a vast canyon system that stretches for about 1,500 kilometers, or 930 miles, roughly 1/3 the width of Australia. These deep scars likely formed when Titania's interior expanded and cracked long ago, perhaps as water beneath the crust froze and pushed outward. Scattered across the landscape are craters of all sizes, from small pits to huge impact basins tens of kilometers wide. The largest, called Gertrude Crater, spans about 326 kilometers, or 202 miles across. Its central peak, the rebound from a massive impact, rises like a frozen mountain in the middle of an icy desert. Another massive feature, Ursula Crater, is slightly smaller but equally impressive, with bright, reflective materials hinting that the impacts once exposed fresh ice from beneath the surface. Titania's relatively smooth plains between these craters suggest something unusual. The moon may have been geologically active in the distant past. The cracks and smoother regions could be the result of cryovolcanism, icy eruptions where liquid water or slushy material once seeped up from below and refroze on the surface. And here's a poetic detail. Like all of Uranus's major moons, Titania's features are named after characters from Shakespeare's plays. From Gertrude and Ursula to Oberon and Desdemona, each crater and canyon carries a touch of literary mystery, as if the moon itself were performing an ancient and cosmic drama. Beneath Titania's icy surface may lie one of the most intriguing mysteries in the outer solar system, a hidden ocean. Though no spacecraft has ever orbited Uranus or its moons, what we've learned from Voyager 2's flyby in 1986 and from later models suggests Titania might not be solid ice all the way through. Scientists believe that deep below its crust, a layer of liquid water, or perhaps a salty, slushy ocean, could exist between the icy shell and the rocky core. This hidden ocean could be dozens to hundreds of kilometers deep. That's tens to hundreds of miles of potentially life-supporting water locked beneath a frozen surface. How could such a distant moon keep water from freezing solid at 200 degrees Celsius, or about 330 degrees Fahrenheit? The answer might lie in radiogenic heat, the slow decay of radioactive elements within Titania's rocky core. Over billions of years, this heat could have been just enough to keep part of the interior warm and liquid. If that's true, Titania could share something remarkable with moons, like Europa, Enceladus, and Ganymede, all worlds believed to harbor subsurface oceans beneath their icy crusts. And where there's liquid water, there's at least a chance for life, even in the most unlikely corners of our solar system. Imagine a hidden sea, completely sealed from sunlight, stretching beneath a surface colder than Antarctica's harshest nights. If life could survive there, in total darkness, fed by chemical energy from the moon's interior, it would change how we think about where life can exist. For now, almost everything we know about Titania comes from a single visitor, Voyager 2. In January 1986, the spacecraft flew past Uranus, becoming the first and only mission to ever explore that distant system up close. During its brief encounter, Voyager 2 captured a handful of images, blurry by today's standards, but revolutionary for their time. Those pictures revealed Titania's canyons, craters, and hints of ancient tectonic activity, forever changing our understanding of this icy moon. But since then, Titania, and Uranus itself, have been left in silence. No probe, no orbiter, no flyby has returned in nearly 40 years. From a distance of almost 3 billion kilometers, or about 1.9 billion miles, Earth can only study Titania through telescopes, and even the best ones can't pierce its secrets. That may finally change. NASA and other space agencies have proposed a mission called the Uranus Orbiter and Probe, a spacecraft that could launch sometime in the 2030s or early 2040s. Once it arrives, it would spend years orbiting Uranus, studying its atmosphere, rings, and moons, including Titania. With modern instruments, this future orbiter could map Titania's surface in high detail, measure its gravity, and even search for signs of a subsurface ocean hidden beneath the ice. Some mission concepts even imagine sending a lander or a cryobot in the distant future, a probe capable of melting through the frozen crust to sample what lies below. If such a mission succeeds, Titania might no longer be just a mysterious moon on the edge of the solar system. It could become a key to understanding icy worlds everywhere, from Europa and Enceladus to the moons of Neptune and beyond. For now, all we can do is look up and wait for the day when humanity dares to return to Uranus and finally uncover the secrets frozen in Titania's depths. If Titania truly hides an ocean beneath its icy crust, could it also conceal the ingredients for life? Until a future mission dares to visit Uranus again, we can only wonder what secrets lie frozen beneath that distant surface. But imagine a world so cold and remote, where sunlight barely reaches, yet beneath its frozen exterior, liquid water might still flow. What stories could this hidden ocean tell about the history of our solar system, or even the potential for life beyond Earth? Until then, what are your thoughts? Could life really exist in the shadows of Uranus's largest moon? If you enjoyed exploring this mysterious world with us, don't forget to like, subscribe, and hit the notification bell, so you won't miss our next journey into the cosmos. Thanks for watching. Until next time, keep looking up.